Hey everyone, Ian Shadden here, and I'm joined with Lauren Ridge,
Hi.
and we're going to be talking about some match 3 stuff, how to get programmers and artists working together for game feel and awesome
Yes.
stuff.
All the things.
So I'm going to start with Lauren here, and she's already set up here to show you all the code stuff that she's managed to put together, and then I'll swap over to me, and I'll show you how to implement that very rapidly in the editor.
Yes.
So,
So
Lauren?
basically, when you've got match 3, you've got 2 tiles that you click on, and they'll either swap and it'll be a successful match, or they won't because you'll be trying to put a blue where a yellow tile needs to be, or something like that. And we want to handle all of the move checking in code because that's when you really want to hammer down the hard rules that you know the game will rely on. So we've got the grid and we've also got the tiles. And so we start with the grid. And if you want to slip to the slides, thanks. So we've got the grid, and it knows when a tile was selected when you either click on it or touch it on the phone. So if 2 tiles can both swap, because we've got those metal blocks that can't swap back and forth, then the grid knows a swap move is pending. So this B pending swap move equals true. Then it checks if the move is legal to see if the pending swap move will be a success or not. And then it calls this on swap move on each tile. So each tile actually handles its own swapping independently. And it knows what tile it's going to switch with and whether or not the move is a success. So the grid talks to the tile and says, you're about to swap, go do what you need to do for the visual swap effect. Once the tile has finished swapping, it just tells back to the grid, okay, I'm ready to go, swap display has finished. It's really just the callback saying the tile has handled what it needs to do, grid, go back to moving the tiles around.
All right.
And that is where you are going to look in your visual shiny things, yes. So once the tile has, or the grid has got on swap display finished, both tiles will report back. So swapping tiles gets added a tile to it. If both of them have reported back, so the swapping tiles number is 2, obviously, it says the swap is no longer pending, so that's false. And if the swap is supposed to succeed, then it will go ahead and swap the tiles, set the last move to a swap, and then go ahead and execute the match. And if the move was not supposed to be successful, then it will just clear out the array and set the move type to failure. So if you remember, this B pending swap move success was actually set by the grid before, in this, if they can swap, then check if the move was legal or not.
Right on.
So the tile will go back to the grid and say, I'm finished swapping. And then the grid actually swaps the tiles at the very basic level. So it says, all right, they've got a grid address that says I'm at spot 1 and I'm at spot 2. Now they'll switch those, so the original one is at 2 and the next one is at 1. And just does all that handling so that if you click on a tile, it knows where it is on the grid.
Right on.
And then it literally forces the location to swap if you want them to. So then, gameplay continues. So to see a little bit of what that would look like, let me close this out and pull up match 3. So right now I selected one tile, and then I'll select another tile. And so on tile was selected is getting called, and it does all of that sort of instantaneously, which, yes, it was a successful match. And look, I've got full bomb power now and all of that, but it doesn't have a great feel to it. Kind of like you want there to be some indicator that you're about to swap correctly. Kind of like here, if you go blue, and then this one shouldn't succeed, and there's no nice feel to it. Right?
Yeah, it doesn't let you know that anything's going on. Yep.
Just like, oh, did I not select correctly? Did I miss a tile? Did I click off? That kind of thing. So what I did is on swap move is that, go back to the slides. Basically the tile handling, it's handling whether or not it should move or not, if it does anything visual. And if you see here, it's actually on swap move implementation is the code side, and that's because it's a blueprint native event. So blueprint native events mean I can be over here on the code side and say, all I care about is the programmer, is that you tell the grid when you're done swapping. Like that's really all I care about. Visual effects, that's up to more the art side of things.
Sounds good. Yeah.
So what that looks like on the code when you actually define the function is we've got onSwapMove here, which takes the tile and whether or not the move will succeed. But you put blueprint native event in the uFunction macro. So you're
Right.
like, this function can have a code example or a code definition, but also we can look at blueprints to see if there's some behavior we need to execute there.
Right.
And then you create this onSwapMove implementation, which is where the code goes for that to get called by the function. So if you want to start setting up the actual swap move,
Sure.
yes.
And that's under tile, yeah?
Yeah, it's on the tile. Every
All
tile
right.
handles its own swap, which is why we actually call it twice for tile A and tile B.
Right. I was actually messing around with this earlier, and I guess I was one of my first runs at it actually had both tiles moving each other around. So you would get double the movement, but nothing really came of it. So here we are in tile, which were all these functions were defined, and we have an event on match for setting off special effects, and play selection effect, which is a little spinny target thing, and begin play. But the one that we want isn't here. So we can go into event, add event, and special game events. And this is event on, swap move?
On swap move.
On swap move. So on swap move,
And if you see it's got the other tile and the will succeed.
will move succeed in our other tile. So we'll be able to know, well, the way that I was handling things is I was like using this to move stuff around and move myself around, but really we can just handle just myself.
Mm-hmm.
So what we can do is, really, there is a way that we had this set up, and it's really cool, or we can just kind of roll with this. So I did something earlier that just simply used a branch, and if it succeeds or if it fails, and then you can say, hey, cool, we can do something completely different if it succeeds or something completely different if it fails. And we could have it jiggle around randomly, or we could have it play noises, or we could have it do whatever we want over here, and we can rapidly bring that all together. Or the much more elegant way to handle it is the way, I believe it was Alan Noon set this up.
Mm-hmm.
Alan Noon set this up, and he's a wizard, and he did it using a series of actually, it's a single timeline with 2 entries in it, and then a select node. So I'm going to go ahead and set up the way he had this set up, and we'll get that working. So we're going to do some stuff here with the sequence. 0 and 1 we're going to get here in a second, but let's go ahead and get the complicated thing out of the way, which is let's create our timeline. So we're going to add a new timeline, and we're going to call this timeline swap move.
Yes.
And in that, we're going to create 2 float curves. And these float curves are going to be for success and failure. So our successful one, I don't know if anybody's worked with the timelines in here, but they're really awesome for doing this kind of movement stuff. So we got a 5-second length, and that's fine. We can choose our play rate at a different time. I'm just going to go ahead and make sure these fit. And then we're going to just start shift clicking in here and creating ourselves some points. And the first one, we definitely want, we don't want anything there, so we're going to put that at 0, 0. Our last point, we want it to be successfully moved, so at time, let's just say, 0.57. Nah, we'll just 0.6. We'll make it nice and round. And we'll take a value of 1. We're going to be plugging this into a lerp node. So all of this is kind of a, it's just going to be a 0 to 1 range. So our movement will be defined off of that. And then this is kind of dull. It's like, yay, we moved. That's
yeah,
cool.
I could have put a lerp function in the code.
Yeah, I know, right? Come on. I was like, there's your linear. There it is. We're done. Okay, go home. But what we'll go ahead and do is we'll make this look way fancier. So we'll go ahead and we'll do a user. We'll come up here. We'll also do a user, and we'll create some different curves here. So I'm going to go ahead and I'm going to break this. Come on now. Give me that. I'm going to drop that down, and then we're going to have it actually overshoot by bringing this one up a little. All right. So what should happen, I wish I could kind of zoom. You know what I'm going to do? These only need to be like, this needs to be one long.
Mhm.
There we go. There we go. That means that reads much better. So we're going to drop down, and then we're going to pop back up over to where we were. So this will give us actually kind of a negative on the lerp, which will actually push us away from where we want to go. And then this will overshoot us and then bring us back down to where we want to be. And then for fail, we're going to have a few more points here.
Ooh, you should actually make this one shorter, because the cool thing about that on-swap move callback is that this delay could take as long as you wanted, and it will just call back
It's
and notify
true.
the grid
It's true.
once it's ready. So this could be actually a shorter.
This could be much easier. We could just do a, well, can it? Because this is a timeline.
Yeah, when it's finished, it'll just
Well, it's finished at 1.
use last keyframe.
Oh, aren't you fancy?
Magic.
All right. All right. So I'm going to create a basic layout here.
But the best part is I don't really have to know as the programmer how long
You don't even have to know any of that. So we'll go ahead and we'll user those, and we'll user these, so we get a nice curve. So these will never go up to 1. So what it'll do is it'll kind of like try, and it'll be like, "Reh," and then it'll be like, nope, and it'll overshoot back, and then it'll drop back into place. And actually, these two need to be, or this one needs to be broken back to user. So we get a nice up, nice down, and there we go. So let's compile, and yeah, that's no big deal. And we'll just go ahead and make writable, because just in case, we'll make that happen. And then when this fires, we're going to go ahead and play from start. All right, so with this kind of more difficult bit out of the way, we know we have a success and we know we have a failure. So we can do a select float. These things are awesome. Allows you to get away without having to use a branch. So really simple, pick A. When do I want to pick A? Well, we want to pick A when this would succeed. I'm going to drop that in there, and then OCD will force me to create some reroute nodes so that we can actually keep a track on it. And then now we will have our values coming out that we'll be able to drive our lerp with, but we need something to drive that lerp with. So, or rather, be driven by the lerp. So we will have we need to know where we want to be and where we are.
Right, and I exposed the other tile's location for you.
Exactly. So we can go ahead and say, hey, other tile, give me your location. Or, well, we'll just say get location, because that'll get it much less. So get actor location. And then for ourself, we will also get location. Actually, I don't even know why I'm doing that, because you can just duplicate it. There we go. And now the grid is completely aware of these locations, and we could actually query the grid, which might be of some use if these were being worked off in local space, or you wanted relative offsets. This is all happening in world space because these are individual actors. So we'll just actually go ahead and query the actor locations. And with that, we can say, okay, well, we have our things we want to lerp to. So let's do a lerp vector. And our alpha value will be the value we just created in our timeline. Remember, that's going to be selected based off of, did we succeed or not? And we want to be, actually now looking at it, since we're not going to be working with the grid, I don't even need a sequence node. So we'll just go ahead and back that all out. Problem solving as you go. So we want to go where we want to go. So the other actor's location, and where we are, our current location.
Right.
And so all of this will be happening. It'll be
I just want to reach out and move that other node before.
No, you want what? You want to do this? You
Yeah.
want to do this? All right.
There we go.
Now, will this actually succeed?
You need to connect
Because this
to the update.
well, no, I was thinking about vinterp 2, right? Like this is a lerp, but we're constantly re-getting our location.
Oh, so we have to store that off.
Yeah, I think we
first.
need to store that location, and that's why you guys were probably using the grid before.
Yeah, because the address doesn't change until that
Until
swap
the
move is
actual
called in
swap
code.
is complete. See, now that makes a lot more sense. So let's go ahead. We'll go ahead and do that then. So we'll go ahead, and our tiles, they have access to the grid.
Yep.
So we'll get grid,
Basically, when they're created, we store the grid as their owner.
and we can get location from grid address. And that's why we needed the sequence node. So we'll go ahead and re-add that back in there. Anybody following at home, I apologize. But it seemed like it would work, and then you get going, you're like,
But I'm going to move it, and I'm going to move it
nope.
more.
But I want to never get to where I'm going. Is basically what we were about to
You
say.
see tile just slide off the screen.
Yep. Goodbye.
But the get location from grid address is actually a blueprint callable function that we made, just so that if you needed to use it for blueprints, you could.
Yep. And then there's another function in here. Well, not a function, but a variable where we're storing our grid address. We'll say, hey, we want to call on the grid, get our location, here's our address. Give that back to us. And then we can do the same thing for self. So we'll just go ahead and grab a reference to self, which just allows me to duplicate these out really quick. I mean, these are just variables. We could actually just pull these in from the side, I believe. Or can we? Or did you not expose the variables in that
I'm trying to think
fashion?
if we made a blueprint pure so that you actually could
so
then
you
go
can
in and
actually
reach
do
in
it?
and set the grid address without going through the code because we know how to handle it.
You're always trying to make things harder on me. I see.
I'm just trying to
I see.
protect you
Programmers.
from just reaching in and
Trying to protect me from myself. I get you. I get you.
You could just reach in and change the grid address, and then the
That's-
grid wouldn't know what to do with it anymore.
Okay, that's fair. No, that's fair. Because I'd be the guy who did that.
You're like, but I want to make the grid address this one.
Yep.
So you got to go through code.
So the nice thing so we fired this off. It's going to come down here, and it's going to say, hey, we're going to have a return value. Now, just because we're using a sequence node, this could all happen in a line. Really, we just need to get this and this first. So we could go to move to get this location to this location to that location, then back up to the timeline. But this compresses it nicely into a stack, so it won't be a mile long as we're trying to talk about it.
Okay.
So now we have our self, and we have where we want to be. So where we want to be, we can plug into there, and where we are, we plug into there. And now we just need to take that value, and for ourselves, we will set actor location.
And because we're calling this function on both tiles at the same time, they
Yep.
can just be sort of independently handling that.
Exactly, they are doing their own thing. And now, anybody looking at this, sitting back there, probably going, yeah, we're done, right? Nope. Need one more thing.
Actually, no, do it without this first, because
You want me to do it without this? Okay,
Yeah.
I'll show you. We'll show you what happens. So we have a success and a fail state. So let's go ahead and there's a move. Let's do that. Hey, wait a minute.
yeah, we swapped, but
Well, we swapped, but
you didn't call back to the parent.
I
and
didn't
say,
call back. I didn't call back and say, hey, we're done.
Yes.
So let's add call to parent function.
Mhm.
And if you're doing these, be nice to your programmer and connect these up, because you never know if they're going to go back through and they're going to change stuff, and they might actually need other tile and on move succeed pass back into them.
Right, because if you didn't hook those up, then other tile would be blank, and then it would always think the move was going to fail, and
Yep.
so basically you'd probably end up with the game locked up like that again.
Yep. So we'll just go ahead and connect those together, compile, save that, play again, and where's a non-successful? Here's a successful match. There we go. Oh, there it happens. And where's something that won't work? Wow, there's a lot of stuff that will work. Yep, there we go. Nope.
And those are, it's
Nope.
a shorter curve, but it still calls back and doesn't, delay for a full
Yep.
second waiting
Because
for
of that,
to call
because
back.
of that timeline awesomeness of use last keyframe.
Mhm.
So.
And
go
then,
back.
yeah, as long as the on-swap move goes, you could call back 3 seconds later or 10 seconds later. Or
Mm-hmm. They
have-
they go floating around each other all crazy like, and so this is one method that we could use, or we could go crazier if we so wanted. What time is it? It is 2:20.
You have totally time to go crazy with the blueprint.
Okay, we have 10 minutes. So we have 10 minutes before I want to start, taking questions from you guys, so that we actually have enough time to get you and get a whole bunch of questions going. So what I thought was more fun, personally. So what we'll do is we'll do this. We'll do a branch, and we will actually run through. If it is successful, we'll go ahead and just use the timeline over here. Okay?
That's a pretty cool timeline.
Yeah, it's actually really quick, really good. And if it fails, though, let's have some fun with it. So we're going to go ahead, and I don't really need all of this information. Really, all I'm going to need is self, the get actor location, because this, I don't really care about actor. Get actor location. And we're gonna break this because we're gonna need to forget to move along Y. We're just gonna want X and Z.
Right, because Y is sort of towards the camera in the way that Match 3 is
Yep.
set up.
So I'm gonna make a vector, vectoron, and we're just gonna go ahead and connect up Y. And so now we have this free and clear something we can do with X and Z here. I know, random floating range. So we're gonna make it freak out on you. And magic numbers before. Actually, you know what? We're gonna do this right. We're gonna want our max. I'm going to promote. And we're gonna call this random range. And for this, compile. Now this is the magic number. We're gonna set it to 5. And in here, we're gonna multiply this by float times float, -1. So it'll be our min range is -5, our max is 5. I'm gonna plug that in up there. And because of the way that random numbers work, we actually need to duplicate this so this gets completely reevaluated.
I've done that before, hook up the same random
Sa-
float
and
to
you're like,
color.
why?
I'm like, why is it always gray?
Why is it always gray? Well, because you're randomly rolling 0.3 for all of them. So now we have sort of this jiggle thing going on. But how are we going to get this to work? Because does it just fire on one frame so they just pop? No. We'll go ahead and my favorite node probably ever, well, okay, the select node is probably my favorite node ever.
Select is
The crazy select node, the one that allows you to do everything. We're going to go ahead and do a gate node. So our open is going to fire when we get a false. And so now we'll be able to come down here and our gate is going to kind of drive this. And what we're going to do is we're just going to use tick. So every frame that this gate is open, we are going to basically freak out the actor location. Let's just duplicate that over there. Set actor location. Bam. So now every frame's going, he's just gonna jiggle around a little bit.
Right,
But
and the gate starts closed, right? Because
Yep, gate starts closed, so that way we're not jiggling right from the start on, well,
just all of the tiles.
just all of the
everywhere.
tiles will be jiggling at all times. It'll be just like,
It's hard mode for
Yeah, try clicking on them now. Good luck. But now we need a way to close this. So, number of ways we can do this. I like using custom events. So let's add a custom event, and we'll call it close gate. And close gate will plug in here, but now we need to call it. Well, we don't want to call it inside here. We could do a big long thing that's like counter, tick, add, greater than, then do something. Or we could do something a little bit more awesome, which is off of our false node. We will say timer. And we will do set timer delegate.
which is a new.
Yep, it's new, it's awesome. And all you have to do is, so our close gate has this little weird red pin right here. If anybody's worked with delegates, just plug it in there. And now we can freely modify our time here and be like, okay, they're gonna freak out for half a second. So when this fires false, so
The move is not successful.
not successful, we're gonna say, hey, give me a timer for half a second. And when you're done with that half a second, fire off close gate. Okay, not a problem. So it's gonna come down here, say open up. It's going to set our actor location to a bunch of random jiggly, and then after 0.5 seconds, close gate will fire, and it'll close our gate off. Now, we are, of course, missing something here, and we will need a sequence node so that we don't get things out of order. And then we could kind of just connect it back up there, and that'll be messy as all get out. But thankfully, that's not actually necessary. We can just duplicate this out. Unlike some of the event nodes and whatever, which
you can only have one
we
event,
can only
right?
have one. Well, the callback to parent, it's like, no, it's cool, just in case you have exactly the situation we're looking at here, where we have a crazy branch. And so when it finishes, they'll jiggle, they'll stop, and then they'll reset. Oh, actually, think about that. If somebody didn't catch that, we need to reset.
You just leave them sort of all over the place.
Actually, yeah, that's actually what will happen because we're not going to reset. So if we're like, nope. Oh,
Yeah, they're down there.
yeah, they're somewhere. Yep.
But the success was right because we didn't change those. So.
But why are they moving to the weird center of the screen?
Oh.
Can anybody tell me why? No?
No.
No? It's actually because we never stored our location and we're added to our location.
So we just sort of.
Yep. So our get actor location down here, we need to make sure that on begin, we'll go ahead and promote that.
Oh, so it's like, okay.
Because we're
this
adding to
place.
0, right?
Yeah.
So promote variable. This will be stored loc. We'll plug that in. We'll plug that in. And then coming off of this, we'll slap this in here. Move that out. We'll want
Put it
our
back to the stored location.
stored location. And then also right here, we want to make sure, because we're
generating some small offset between.
Yeah, since we're setting this, we're just kind of like freaking out, but this is kind of wrong because what we actually need to do is make sure this is added to our a fixed location. If not, then we're just going to keep on adding to, and it gets kind of ridiculous. So we'll go ahead and store loc. I'll go ahead and break.
I guess you also could have used the get location from grid address because the address doesn't change again until after you finished moving.
It's true.
So
Actually, I don't even need to do this, do I? I can do this. There's our made vector, and then we can just add. Simplifying as you go. Vector, vector. Plug in.
and there you go.
New location. So we're adding a random amount to our stored location, and then at the end we're resetting it back down. And so this should be 0 and a range of 5 to -5. Our stored loc is never recalled. It's never reset. So it should kind of just jiggle in place. But I was noticing something weird before, but let's see if that was just a
And side effect.
side effect of, yep, there we go. No, I don't want to. And if you can just imagine the sound that could make. I know.
We just record you saying nope.
Nope. Nope. Nope. Yeah. So actually what we're going to do now is we're going to go ahead and check out our questions that we have available. And we'll go ahead and see what we can answer out of those. And let's see, where's that?
While you're pulling that up, I just wanted to mention, like, because I'm just calling onSwap move from code, you could attach all sorts of crazy things to the onSwap move node, because all it does is look at the blueprint, execute the blueprint, and then if you call the parent, go back and call the onSwap move implementation.
Yeah, we could, if we really wanted to, I mean, we could go completely nuts down here, and we could add particle effects while it's trying to move around. It's just streaming stuff everywhere.
The camera's shaking.
Camera's shaking, and the grid could just, everything could fall off. It's like, nope, you failed once, and the game's over, right? We could kill the game from this point. And so it's, yeah, this is definitely opening it up for your designers to iterate to their heart's content without crazy build times in between. Because if you were trying to do this,
right?
I mean, at most you're talking like, well, or at least you're talking 15 seconds per build.
Well, to recompile, and also, that's not really what I want to, work on programming. So I can be like, oh, I'm going to go make another game mode where it's turn-based instead of timer or something.
Right, or go work on multiplayer for this or something, right? Like, and then you can pass it off to a designer, make this feel good, and we can make it feel good.
Exactly.
All right. So, let's see. Is the move object always drawn on top when trying to do a move?
I don't think we actually adjust the Y, but you could to be like, oh, we always want, but just basically like right when you do the timeline swap.
Yeah, I believe the render component, it has a, it's a Z offset or something like that. What was it called? Sort. There we go. Yeah, so translucency sort priority. I believe these are still translucent, regardless of the fact that we clip their edges to make it more performant. But this would allow you to decide which one goes forward or back.
Or if we were still using mask materials or something, you could easily just adjust one and Y so it is closer to the camera and then comes back in.
Right, but how would you do that if they're both moving themselves? do you would have to pass along, am I the first tile or the second tile?
Yeah.
And then the first tile could be like, oh, hey, I'm the first one, I move forward, and the other one's like, I push you back.
Right. Or just, subtract the grid addresses, and if one is positive, go
Mhm.
off that. So you could actually do that without even an extra code change.
But the grid addresses would be
One will always be greater than the other.
right, but it could happen in any direction.
Mhm. I mean, it would just be like you would just want to put one in front.
Right, but I mean, one already goes in front.
Mhm.
I mean, that's, yeah.
Yeah.
Well, actually, so what happens, it looks like, is they swap midway.
Mhm.
So, yeah, that means they're just being sorted naturally by translucency.
Mhm.
So we could set them to be, we just need to know which one's coming in and set one forward, one back.
Right.
One's a 1, the other one's a 2.
Yeah.
And you're done. And then you reset them both, all to -1 when you get to where they're going.
Yeah.
And
There's a
probably
ton
be
of
the
ways
easiest
to-
way. Yeah. Because the movement one then starts getting into, well, it could be more interesting because at that point, then you could have 2 timelines running and one controls your depth. And so
It actually does sort of curve up
yeah,
and then
it's
back
like
down.
right, like it like pushes in and pulls out like really hard, so you could get a nice depth effect going on. If you wanted, I mean, for I guess a more 3D game, or maybe if you're making match 3 for Oculus, I guess I don't know.
The tiles, yeah.
Yeah. Has anyone found a way of setting up stereoscopic display suitable for 3D screens, not HMD? Found a way of setting up stereoscopic displays suitable for
It's basically not VR, but just a 3D.
just like the off
3D
the shelf.
thing, yeah.
I
I don't know that we looked into 3D Match 3.
I don't think. Well, I don't think anybody's really looked into doing that for. I mean, it's the same basic process. It's just those, depending on the type of display, back and forth. Like it's just LCD flipping one eye off, the other one on. So really, it'd be, instead of rendering to two different spaces on a screen, you'd be rendering to the same space, just one camera, 2 camera, 1 camera, 2 camera, 1 camera, 2 camera.
Yeah.
So, and then you just have to sync it to the glasses. But I don't know if anybody's actually done that here.
Yeah.
That doesn't seem to be something that's been passed around, if it has.
Yeah. But now I want some sort of crazy 3D Match 3.
Yeah, no, you want 3D Match 3? No? Okay, we're going to put it in the Oculus now. All right. And then Alexander is...
That's the same question. It's just there
Yeah, it's the
twice.
same question.
But here, let me go back to the code real quick. I want to show the swap move
All right.
thing.
There you go.
So, here we go. So, like I said, the Blueprint native event means that on-swap move is the event that you see.
Mhm.
On-swap move implementation is the one that then I would override. Say we made another tile type, like say our bomb was actually a subclass of tile instead of the same tile, just different art.
Okay.
And so you actually put virtual on the implementation, not the one that's just undecorated, because that's the one you'd override in code. Like that's the one the programmer cares about. But go back to the original slides here. So on swap move, you just refer to it again by on swap move, not on swap move implementation, because that means it will go look at the blueprint and then the code. If you just wanted to do the code implementation and not care about then going to look at the blueprint, you could put implementation here, or just take off the blueprint native event. But like I said, I just care about when it gets called, which is if the 2 tiles can swap. I don't care about, or I don't necessarily need to design the part for when they go back and forth.
Right.
So, if there was any other, I know there were some other effects that you'd set up in the tile blueprint if you wanted to.
Yeah, there's actually not a ton of questions today.
Yeah.
So really, some of the really messy stuff that I ended up doing.
I don't know.
I don't know what you're talking about. So in this section of Blueprint,
Okay,
it's actually really just a, we'll talk about some more of the arty stuff. So,
Well, because these are all, again, on matched is an
Yeah.
event I set up in code and was
Yeah.
like, have at what happens when they match.
yep. And she created an enum for us to pull off and be like, okay, cool. So what kind of match was it? Was it none? Was it a failure? Was it a swap combo bomb, or all the bombs going off? And this used to have like a bunch of different effects, but we kind of simplified things down. And really what happens is that the explosion scale is set differently for when everything either it's just a simple match or if it's a bomb or a huge explosion. And then pull out here, we can tell, just by the reroute nodes out there that there used to be a lot more going on back here. But really it's just a set of we doing a for loop, getting all the materials, creating dynamic material instances for our basically what will be our whatchamacallem, our
So the
particle
tile,
effects.
the particle effects pull the tile color that we've
They
stored
pull
in
the
the
tile
library.
color, yep, and then they detonate into the shiny colors, and then we're setting some translucently set priorities so they're up front, and then we're setting our world scale on our explosion, which there's our spawn emitter down there. So all of this happens, since all of this happens in a frame, you never see for a moment that you have a spawn emitter with no color, right? It's just there. And so you can actually see it. Well, here, let's make something a little more obvious here. Let's do our default scale of like 0.1, 0.1, 0.1, and then we'll do all the bomb scale of 333. So that way, this is one event being called, but if we do a small match, it's like, oh, they're barely even there. They're kind of cute, right? Oh, feels really weak. But then when they combo, oh man, they're getting pretty beefy. And when they bomb, they combo pretty well too. Now let's see if I can get up to fill up my power bar there.
So much pressure to get all the matches now and find the combos.
I know, right? This is gonna be the one time and it's like. Also, I could try actually looking for them.
But the thing is that the particles have that translucent sort priority, so just like that, we could, like you said, with the tiles, make one sort in front of the other one.
Yep. Okay, so there's all the bombs, and now, oh, good lord. Yeah.
And you never get all the bombs again because
Nope.
you can't see anymore.
Just got another one. Yep. Yeah, you can't see anything. But, then a designer could come back there and be like, why did you do this? Why?
Tweak it back, yeah.
Yeah, I'd be like, no, you just don't touch this again. And maybe we want bombs to be slightly bigger than a combo, so maybe we just take combo down to 0.65, 0.65, 0.65, and then we take a bomb up to 0.8, 0.8, 0.8. That way there's at least a variation on them. And we could do more from this. I mean, this is splitting off and showing, this going on. We could have a variable over here just like this that we'd set and say play rate. Or
Either
extend the
like
lifetime, they
yeah.
stay longer, or they play slower. And this is all in the hands of your designer rather than the programmer sitting there going like, oh, I gotta make the arts.
Well, that and there's I think a reference when you spawn the particle system to the emitter and hard coding those. If you move it or rename it,
good
then
luck.
you got to go update the code. But if you just fix up your redirectors, then it's easier.
Then it's easier, much easier. And then what was the other thing that we ended up working on? Oh, well, there was the grid, but was that actually exposed? Or was that just something that I magically put together?
No, we did the swap move because the thing is, again, if you've got a tile effect and then all of the tiles, you blow them all up with all the bombs, you're going to have, 20 different things going on. You don't want to do that with 20 noises or 20, score printouts or something like that. So that you want to handle on the grid.
Yep, and also on the grid, we do the combo speed.
Oh, yeah.
So, unfortunately, or just the way that it works in code, that if you were to swap something, like this just falls down, right?
It's just basically a lerp. That's why, lerps are much easier to set up in code, but, for pretty curves and things, that's probably when it switches timelines.
Exactly. You want some level of acceleration. So I actually went through and created, based off of what kind of match you have, it'll start accelerating through combos. That way, I mean, the timer pauses, which is nice while everything's falling, but if it was falling like this at all times, you would quickly get bored and walk away.
Well, that also, you want the combos to feel like they mean something, right?
Right.
So
they hit harder, and so things start accelerating down, bombs automatically go faster. That way it feels more intense. Now, you get some camera shake going in there, that'd be even better. But all of this is just driven through, hey, we have a match move, and
it knows it's a combo.
Yep, simple combo counter thing where we're like, oh, cool. So our combo is X, so we're going to take our base speed times our combo counter, our base speed times 1.25 times our combo counter. So if this is 0, whatever, and it's just base speed. If it's 1, then, hey, great, we're going to go faster. And then I'm doing an F interp 2. That accelerates. So interps are really, really nice for getting something to kind of like ease in, rapidly accelerate, and then ease back out. But if you ever want them to hit something and not wait a long time, you
Sort
either
of
have
feel
to
like they slam into place, right?
yeah, so you have to go ahead and accelerate that back into place, or else they kind of just they're very squishy. They feel great for squishy things, but they give you if you accelerate them, they give you a nice curve.
Right.
Um,
It's that easing in and easing out.
easy in and easy out. Yeah, exactly. I don't know if anybody noticed it, but there is a logic error through here that I haven't fixed yet, which is if you set off a bomb or all the bombs and you had a combo previously, you actually get your combo speed added to your all the bomb speed. So
That just
things end up
means
going really, really fast.
It just means you want to set off all the bombs. I don't know
Yeah,
if it's
I
a
mean,
logic error. That's a make things go
Does
faster.
it make things go faster error? All right, that's fine. But it doesn't do it if you didn't have a combo prior, like,
yeah.
right? Like, you actually have to get, like, one combo going, and then it offsets everything.
Yeah.
But anyway, well, I'm going to actually open chat here just to see if anything's flashing by in case Alexander and the like are being a little slow. But no, there's something about a pool stick. So I'm not entirely sure there's anything here. Yeah.
But yeah, I mean, the main reason we wanted to do this stream in particular is to show like that I can focus on, or programmers in general can focus on
Yeah.
writing the things that like are integral to the game rules. You don't want somebody who's just tweaking game feel to be able to say like, this is now a match or this is now a
Yeah.
failure.
Yeah.
But on the other hand, I don't have to be fiddling with the variables of like visual effects and
Right.
the game feel. I can just, sort of hand over some functions. You can go do those in blueprints, and I can keep going on something else. So it's like both people get to, work on like their wheelhouses kind of
Yep.
thing.
And they can basically do it in parallel.
Yeah, I mean, we think handed over, or like got before the art pass, just coded a bunch of functions. Said here's the hooks,
Mm-hmm.
but didn't have to wait on anybody, that kind of thing.
Yep.
So.
And the game was completely functional outside of that. So you could get the feel for, oh yeah, the score's working. Yeah, combos work. Yeah, okay, that's great. But then it's still kind of bland at that point. And then as it starts to actually come together with art input and design input, it's like, oh no, this feels great.
And that's the other thing too, is we didn't have delays at first. So before we had the on swap move, you just had the instant tiles like, oh, now I need to be here, so I'm gonna instantly be here. And that doesn't feel great. But we had to put that callback in so that we knew to wait, right? That on swap move, so it just knew, okay, now that this shorter move is finished, go back to code, and the code goes, okay, now I can keep going.
Exactly.
So basically, there are things that make more sense to do in C++ and in blueprints, and it really depends partially on your team makeup, but also on your game design. Like that crazy thing you did with tick, I'd probably move to code eventually because
because it's a tick.
Yeah.
I mean, it's straight up just tick. And gates are handy. They're one of my most favorite blueprint things ever. But they do have. I'm pretty sure there's a gate functionality within C++. Have to be.
Well, basically, you'd use something, another callback like that of just, start ticking and end ticking. In fact, I think actually our falling code is kind of like that.
Okay.
So go and open it up. Which means I go digging through things for a minute. So here in code we've got basically on tile finished falling and start falling are two pieces of code we did. And what happens is, let me go to the C++ and find. Is it on the grid? I thought it was. Oh, yeah.
Got a number of results.
Yeah, so on tile finish falling. Again, that goes to the tile and says, you start falling, go do whatever you need to do. And then the tile calls back and says, on tile finished falling. So the tile itself has got the, let's see, ticked, tile selected. So yeah, start falling basically just does a little bit of a tick here. Set timer for a really short time, repeat, and then once it's reached this location, calls back and says, okay, stop, I'm done.
Right.
And that's sort of like a gate functionality, right?
Exactly.
Keep doing this thing until I phone home and say, I'm done.
Yeah, gates are what a lot of people, when they first get into blueprints, they want a do while to do, right? That's what gates are in the mind what they should be doing.
Right.
A do while isn't that, right? It's logically, it's like, while this is not this, do this, and I'm just going to take all your resources and do that. Gates are, no, do this thing every time this is received,
Right.
and I am open.
Right. Like every time that I'm still in this state, execute the task. Whereas do while, we'll just keep doing that until.
Exactly. Until you run out of resources or
Right.
heat death of the universe, whichever, comes
Yes.
first.
So, see if there are any other questions.
No, I don't. We don't. Alexander Brandon was asking some stuff about, how much in C++ versus how much in Blueprint, and it looks like he got kind of answered out with the idea of do a whole bunch of stuff in Blueprint first and then take it back to C++.
Yeah, or it really
Great for
depends on
prototyping.
the team makeup too. Like we had
Yeah.
Richard and I were working on the code side, and they're like, okay, art is not our wheelhouse.
Yeah, and
Ian
then they passed it off to us, and we're like, everything's in Blueprint.
Right.
We didn't bother redipping back in, but now that we've done something, we could pass that back and be like, hey, make this more performant.
Right.
Depending on if it's even really worthwhile to do so. I mean, part of the trade-off there is, yes, you could spend a whole day trying to make that more performant, but doesn't matter given the total footprint of the game.
Right. And then we've got other learn samples, like shooter game is almost all code,
Yep.
but then you've got like multiplayer shootout, which is all blueprints.
All Blueprint.
And it, again, what's in your wheelhouse? Try to do things in code that are on tick, or are going to move a million AI bots chasing you. But we've got some docs on that online too, like best practices, how to write functions. Like the Blueprint native event, I know that I need some code behavior and some Blueprint behavior. But you've got Blueprint implementable events where I don't even care about the code side. It's just, here's a cool event for you to hang some shiny art on.
Yep.
So.
Alrighty. Well, with no more other questions, I think we're gonna call this one just a little bit early.
Yes.
If there are any questions and you guys just we missed them, or
We'll check them out on the
we'll check them out on the forums.
Yeah.
I mean, we're there for you guys. So
And this is definitely going to be an ongoing thing. I mean, it's a
yeah,
big
we have
game.
more to talk about.
We're
on this
adding
thing.
more. I mean, this may not even be the effect that's there when we're done, because you could just hook up a new blueprint tomorrow and
Yeah.
yeah.
Maybe we can get Alan Noon on next time, and we can talk. Well, me and Alan Noon, and we can talk about the original effect that we had in there for stuff exploding and what he created, and why is that more performant? Because it does a hell of a lot more than what I was doing. And mine was simple. Mine was just like a polygon, whatever. But his is just.
This
whatever.
one I want like sparkling sound effects, all the
I know,
overlap
just
and
tinkling glass
Yes.
or something. But anyway, take it easy, guys. We'll talk at you next time.
yes. See ya.